The next part of our programming screencast is we'll see how do we do search on the small world networks. Search on the small world networks, and as we have discussed before, the search on the small world networks is known as a decentralized search. Decentralized search because it's a collaborative effort. There is no central authority, no central node in the network which helps you searching, and we have briefly looked at how do we do this decentralized search, right? So how do we do this decentralized search was something like here is a node in this network, and let's say this is the source node and it wants to find a path to some node, let's say the target node. Let's say it wants to pass on some letter to this target node. So how this source was going to work is it was going to look at all of its neighbors, and for all of its neighbors it has an estimate of the distance of its neighbors from the target. So the source looks at what is the distance of this neighbor from the target, what is the distance of this neighbor from this target, this neighbor and this neighbor, and it might find out that this neighbor here is closest to the target. So it chooses this neighbor, and this neighbor again here, this neighbor again here looks at all of its neighbors and then chooses the one which is closest to the target. And then this one looks at all of its neighbors and chooses the one which is closest to the target, and hence the letter, in this process, the letter reaches the target. Now, what we are going to do this, we are going to look at how do we do this decentralized search on our small world network, on our Watt-Strogatz model which we have studied before. So, given a Watt-Strogatz model, how do you perform a decentralized search on this model? So let's say the model which we are talking about is that is a ring model, the one-dimensional Watt-Strogatz model, and we want to see how do we perform a decentralized search over there. So let me tell you, this kind of search is known as the myopic search as well. So we call this decentralized search as myopic search. Why myopic? Do you remember myopia? We have studied it when we were in like 6th or 7th or 9th class, I don't remember. So myopia is nothing but the short-sightedness. Short-sightedness means that you can only look at a small distance. You can't look at a long distance. And that is what happens in a decentralized search, right? You don't know about the entire network. You know only about your locality, and based on your locality, you decide where you want to pass a letter, and hence myopia. And hence this search is known as the myopic search. Let's quickly see how do we perform a myopic search before starting with the screencast. So let me take a one-dimensional Watt-Strogatz model here, and let's say I take here 10 nodes arranged on a ring. So 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So here I take 10 nodes which are arranged in the form of a ring, and for the sake of simplicity I am going to connect each node. So the homophily links each node one edge towards its left and one edge towards its right. So these are the homophily links in this network in the form of a ring. And next my aim is to lay some weak ties in this network. So I am simply instead of rewiring as we have discussed before, I am simply going to add some edges here. So let's say I add an edge from 10 to 6, and then I add an edge from 1 to 8, let's say, and let's say one from 4 to 8, and these are the three weak ties in this network which makes this world small, which makes it a small world network. Now how do we do a decentralized search over here? So let's say our node 1 here is the source which has the letter, and let's say the node 6 here is the target. We want to pass on the letter to this target which is the node 6. Now how do our myopic search, how do our decentralized search work here? We have seen before how does decentralized search work. Every node is going to look towards its neighbors and then choose the neighbor which is closest to the target. Node 1 here. So node 1 here, it is supposed to pass on the letter to the node 6. So according to our myopic search, decentralized search, it will first look at node 10 and then look at the distance of this node 10 from the target. Now here I would like to tell you, when you look at the distance of your neighbors from the target, you do not have information about the weak ties which your neighbors is connected to. So I might know my neighbor and I would have an estimate of his distance to the target. I will not be knowing the weak range ties of my neighbors. The weak ties I won't know. I'm very sorry, long range contacts and the weak ties of my neighbors I will not know. I will know my weak ties, my long range contacts, but not the long range contacts of my neighbor. So the node 1 here knows that he can pass on the letter to the node 10 and he can pass on the letter to node 8 or to the node 2. And then he calculates the distance. For node 2, what is the distance from the target? It is 1, 2, 3 and 4. So the distance of node 2 from the target is 4. And then he looks at, the node 1 looks at node 10, and what is the distance of node 10 from the target? Since he doesn't know the long range contacts of node 10, he will calculate the distance of node 10 to be 1, 2, 3, 4. So the distance of node 10 from the target is 4. And then node 1 also knows node 8, whose distance from the target is 2. So what will happen according to the decentralized search or the myopic search? The node 1 will pass on the letter to this node 8 over here. And now this node 8 over here has the letter. And then this node 8 looks at all of its neighbors. Node 9, whose distance from the target is 3. And then node 1, whose distance from the target is 5. And then node 4, whose distance from the target is 2. And then node 7, whose distance from the target is 1. And it will simply pass on the letter to node 7. And then node 7 will look at all of its neighbors and the target is its neighbor. So it will pass on the letter to the target. So we can see here that this is the path which our decentralized search will find, and the length of this path is simply 3. My next question to you. Now we understand what is decentralized search, what is myopic search. Do you think this search policy is optimal? What do I mean by optimal? Optimal means, do you think that it has found out the best path? Can you find a path from this node 1 to node 6 in this graph, path from node 1 to node 6 whose distance is less than 3? And it's actually possible. So if you look at this path over here, you start from node 1 and then you come to node 10, and from node 10 you can directly go on to this node 6 over here. So there is a path of length 2 from the source to the target in this network, but our myopic search has found out the path of length 3. So it concludes that our myopic search, our decentralized search, is not optimal. It's not optimal, but still it gives us a path of quite less distance with less knowledge. So when we were walking to find out the optimal path from node 1 to node 6, we have assumed that we have the global knowledge about this network. So anybody who is knowing this entire network can find out this path. But if you know only the information about your locality, about your neighbors, which is true in the real world, it is difficult to get an optimal path. So you follow this greedy approach, which is called the decentralized search, and find out this path. So we will be doing this, and what we will be looking at in this programming screencast is, let us say here are the number of nodes in our network. Say here are the number of nodes. Mainly you can make a ring having 100 nodes. You can make a ring having 200 nodes. You can make a ring having 300 nodes, and so on. So different sized rings we are going to take. Of course with the weak ties over here. So different small world networks, one-dimensional small world networks we are going to take. And then we are going to do decentralized search on these networks, and we will be looking at what is the average time taken. What is the average time taken to find the distance, to find the path from the source to the target, how many steps are taken, and we'll see at how does this plot look like, whether it is order of n whether it is order of n square or order of n by 2 or order of log n or order of log square, and what is it? We will be looking at this in the second programming screencast.